Another argument for the spherical shape of the Earth, that is also based on observations of a lunar eclipse, relies on the local time of occurrence of the eclipse. When a lunar eclipse occurs, it occurs simultaneously for everyone on Earth. Those who can see the moon at that time will find the Earth casting a shadow on the moon. Those who can't see the moon at that time will not see it being eclipsed. But the phenomenon of the moon going into the Earth's shadow is something that is objectively happening. If the Earth was flat, then the moon, when it's above the plane of the Earth, would be visible to everyone on Earth. So everyone on Earth would be able to see the eclipse at the same local time. Just as the time of sunrise has to be the same for everyone on a flat Earth, the time at which the lunar eclipse is happening should also be the same, assuming that everyone is recording time based on the position of the sun. But if the Earth is curved in the east-west direction, then the local time of sunrise will be different for different people, as we've seen before. In this diagram, I've shown a lunar eclipse happening. The sun is far below the Earth here. You can't see it in the diagram, but you can see the rays of the sun coming. The region between these two gray lines is basically the shadow of the Earth, and the moon here is shown as in the process of entering the Earth's shadow. Now you can see in this diagram that a person at point C in the east is shortly going to experience sunrise, because the sun is going to travel around the Earth in this direction. Right now it's below the Earth, and it's going to come out from under the Earth and travel in this direction. So a person at point C is about to experience sunrise. So the local time at C is shortly before sunrise. A person at point A in the west just experienced sunset a short while ago, because the sun went down under the Earth in this direction. So the sun was earlier somewhere over here or in this direction, and it went down. The local time at location A, therefore, is a time that's shortly after sunset. It's sometime shortly after sunset. A person at point B in the middle is experiencing a local time somewhere close to midnight, because the sun is exactly on the opposite side of this point. So this also means that the local time at which people in the west and east are seeing the lunar eclipse is also different. For people at point A, the sun has just set when they see the eclipse. For people at point B, the eclipse might be occurring close to midnight. For people at point C, the eclipse is occurring shortly before sunrise. And this is in fact what observations show. Ptolemy says in the Almagest, we find that the phenomena of eclipses taking place at the same time, especially those of the moon, are not recorded at the same hours for everyone. So eclipses of the moon, lunar eclipses, are not recorded at the same local time by different people on Earth. We always find later hours recorded for observers towards the east than for those towards the west. And since the difference in the hours is found to be proportional to the distances between the places, so the difference between the local times is found to be proportional to the distances in the east-west direction between the places, one would reasonably suppose the surface of the earth to be spherical. Well, based on this particular observation that the local times are different when a lunar eclipse is happening, we can, strictly speaking, say that the earth is curved in the east-west direction. It must be curved in the east-west direction, because if it wasn't, then the local time of occurrence of a lunar eclipse would be the same for everyone on earth. But if the earth is curved in an east-west direction, then you can expect a difference in the local times. Some places on earth might experience the lunar eclipse shortly after sunset. Some places might experience it shortly before sunrise. Other places might experience it somewhere around midnight. So there will be a difference in the local times when if the earth is curved in the east-west direction, and that is in fact what we see, that there is a difference in the recorded local time of occurrence of a lunar eclipse, and that shows that the surface of the earth must at least be curved in the east-west direction.